With today's lesson in quadratics, we're going to be discussing the discriminant. The discriminant is going to allow us to find out how many real possible solutions there are when our y is equal to 0. Before we can do that, let's go ahead and talk about the standard form of quadratics again. Alright, again we're going to have ax squared plus bx plus c, where a is the number in front of x squared, b is the number in front of x, and c is the number all by itself. And then the standard form, especially when we're dealing with trying to solve a quadratic, needs to be equal to 0. This is especially important when trying to use the discriminant formula. So once your quadratic is set equal to 0, we can go ahead and use this formula, b squared minus 4 times a times c, to find the discriminant, or the number of possible real solutions. So when we're given a problem like negative 3p squared minus 2p minus 1 equals 0, I can see that it's in standard form because it's equal to 0. My a will be negative 3, my b negative 2, and my c, the number all by itself, is negative 1. Alright, for me to be able to find the number of possible solutions, I'm going to plug the a, b, c into my discriminant formula. So b squared will be parentheses negative 2 squared minus 4 times negative 3 times negative 1. Now it's important to use parentheses, especially when we're multiplying, so as that the calculator does negative 2 times negative 2 and not 2 squared times negative. So when you are using the calculator, you're going to want to put it just as you see it. So my calculator gave me a value of negative 8. So with the discriminant, it's not necessarily the 8 that I'm interested in, but whether the discriminant is going to be positive, negative, or 0. If my discriminant in this case is negative, I'm going to have no real solutions. If my discriminant is positive, I'm going to have 2 real solutions. If my discriminant comes out to equal 0, I'm going to have 1 real solution. So let's go ahead and talk about what that means. Alright, in this case, my discriminant was negative 8. And it's not the 8 that I'm interested in, but the fact that it's negative. So in an xy coordinate plane, we said that our quadratic was equal to 0. So y equals 0. I want to see how many times it crosses the x-axis. Well, if it's a negative number, my quadratic will never cross that x-axis, meaning I will never have any real solutions. So when y is 0, x can never be an answer because that quadratic never touches the x-axis when y is 0. When I have my discriminant equaling 0, I have 1 real solution because my parabola touches the x-axis at one spot, right at the vertex on the x-axis, giving me 1 real solution. When my discriminant is positive, my quadratic, my parabola, crosses twice, giving me 2 real solutions when y equals 0. So we just completed number 1 in your homework with the last example. Let's look at number 2. My a, b, c is needed to use the discriminant. And again, the discriminant is going to be b squared minus 4 times A times C. So in number 2, my A is negative 4, my B is 5, and my C is 7. So I'm going to use parentheses with the squared. My B is 5 minus 4 times negative 4 times 7. I'm going to plug that right in my calculator as you see it. So after plugging it in my calculator, we got the discriminant to equal 137. Well, 137 is a positive answer. And then like in the last notes, we said that a positive answer means we're going to have 2 real solutions. So our parabola, when we were to graph this, may look something similar to this, crossing the x-axis twice, giving me 2 real solutions. If we look at number 9 in your homework, we're going to do the same thing. Find your A, B, C first. Your A is 4, your B is 8, and your C is 4. So using the discriminant, right, we have our B squared minus 4 times A times C. So we have 8 squared minus 4 times 4 times 4. Alright, so plug it in the calculator as you see it. So as you can see, the discriminant equals 0. And from the notes we took in the beginning, that means that I'm going to have 1 real solution. And that's going to look like this, perhaps, where the parabola will touch the x-axis at 1 point, giving me 1 real solution. So to finish up today's lesson, just as a reminder, before you can find the discriminant for any of these quadratics, they need to be in standard form. They need to equal 0. So if you look at 13, 14, 15, and 16 here on your homework, none of them equal 0. So for 13, what we can do is we can subtract 2 from each side, leaving me with 9a squared minus 6a plus 3 equals 0. Now I'm ready to find my A, B, C and plug it into the discriminant formula. Number 14, same way, subtract 3 from each side of the equation, leaving me with 6v squared plus 6v minus 3 equals 0. I'm all ready to find my ABC and plug it into the discriminant. Alright, and then 15, I can add 2 to each side, leaving me with 5x squared plus 6x minus 3 equals 0. Alright, then I can find my A, B, C, plug it into the discriminant. If I have a negative answer, I know I have no real solutions. If I have a positive answer in my discriminant, I know I'm going to have 2 real solutions. And if I have a 0 as my discriminant, then I'll have 1 real solution. Again, subtract 7 from each side for 16. Negative x squared minus 4x minus 7 equals 0. Find my A, B, C and plug it in that discriminant. Again, that discriminant is b squared minus 4ac. All right. Good luck.